In this video, I'm going to investigate whether the series summation n is equal to 1 to infinity ln of n divided by n square converge. Now, in order to do so, I'm going to go ahead and use the integral test. Now, in order for us to be able to use the integral test, we need to make sure that we define a function that kind of goes with the series, as well as it has three properties or three attributes. So let's define the function first. It's going to be f of x is equal to ln of x divided by x square. And then this function has to be defined. It has to be defined from 1 to infinity, and the range is going to be real number. And let's call this d for domain. Now, three things this function has to satisfy. One is it's decreasing, another is it's positive, another is that it's continuous in the domain. So let's go ahead and do this. So number one, is it decreasing? Okay. Look, ln of x over x square. As x gets bigger and bigger, so does ln of x, so does x square. However, x square dominates over ln of x. Ln of x increases, but very, very slowly. All right. So this function is actually decreasing. Yes, it is decreasing. Number two, is it positive? Okay. Yes, the function is positive in the first case when x equal to 1 is 0, but other than that, it's always positive. So, yes. Number three, is it continuous? Is the function continuous on the interval? Obviously, there is no 0 that we have to deal with for x value in the denominator, and in the numerator we are okay as well, ln of x, because it's defined on the positive from 1 to infinity, positive numbers. So yes, obviously it's fine, it's continuous, yes. Now we are going to define an is equal to f of n, which, by the way, you will see is nothing but ln of n over n square. Now, since all three conditions are satisfied, we can say that we can apply the integral test and say if the integral converges from 1 to infinity, the series will converge. If the integral diverges, then the series will diverge. So let's find out what happens to this function when we integrate over the domain. So it goes from 1 to infinity ln of x over x squared dx, which, by the way, I could write as limit t approaches infinity integral 1 to t ln of x over x squared dx. Now let's just go ahead and do the integral, which is something you probably already know. Let's go ahead and take care of the integral first. Integral ln of x over x squared dx. We are going to make the following substitution. Let's say u is equal to ln of x. That's going to give me du over dx is equal to 1 over x, or du is equal to dx over x, and dv is equal to dx over x square, right? If we integrate both sides with respect to the corresponding variables, then we are going to get v is equal to negative 1 over x. So this is going to be equal to integral u dv, which is going to be equal to uv minus integral v du. uv is going to be, u is ln of x, v is this, negative 1 over x, so it's going to be ln of x over x, right? minus integral v du. V is negative 1 over x. Du is here dx over x. That's going to give me negative ln of x over x. This negative and negative is going to make it positive. Integral dx over x square. If I simplify it further, it's going to give me ln of x over x minus 1 over x. Integral dx over x square is negative 1 over x. So this integral is actually equal to this. Now I can go ahead and substitute it here. So it's going to be limit t approaches infinity, right? Then integral 1 to t ln of x over x squared dx. So that's going to be, let's put it inside a square bracket, negative ln of x over x minus 1 over x goes from 1 to t. So that's going to be equal to limit t approaches infinity. Okay, so this is going to be, if I simplify it, it's going to be, I'm going to write down this value first. Okay, because it's going to be positive, that's why. So it's going to be 1, because 1 over x is just 1 when x equal to 1, and negative is going to get cancelled because you're subtracting, right? Similarly, ln of 1 is 0. So this is going to be just 1, and then minus ln of t over t minus 1 over t. Now, this in essence boils down to the following: 1 minus limit t approaches infinity ln of t over t minus limit t approaches infinity 1 over t. Now, as t goes towards infinity, this obviously goes to 0. What happens to ln of t over t? This one. As it turns out, you can use the L'Hopital's rule, and you'll see that this guy also goes to 0. So in essence, the integral boils down to nothing but 1. So that's what it is. So the integral does in fact converge, right? This integral, it does converge. So by integral test, summation n is equal to 1 to infinity ln of n over n square does converge as well. So once again, by integral test, ln of n over n square summed over 1 to infinity does in fact converge. I hope that this discussion was helpful. Thank you very much.